Hi Rakesh, can you hear me?
Yes, Rahil. Loud and clear. Can you please share the screen?
We'll start the webinar. I think we'll just wait for a couple of minutes and then we can start.
All right.
Kanika, could you please make Toshif the co-host?
Done, Swashri.
Okay.
Hi,
Hi
Toshit.
guys.
Can you hear us?
Yeah. Can you guys hear me?
Yeah, loud and clear.
Okay, great. So should I share my screen now? All right, guys, we'll begin the session. Thank you all for joining us. I hope everyone is doing well. We'll start with the session, and I think the guys who are joining will be able to pick up from there. So let's begin with the masterclass today. We basically have about 1.5 hours that we have taken, but we'll try to finish it earlier than that, and we have a session for question and answers for you guys. So if you have any questions, you can just keep noting them down, and we'll have time for questions at the end of the session. All right. So we'll begin with the agenda. Okay, so what we are going to be looking at here is we'll be obviously introducing ourselves, what is CloudX, what is Reddington, and what we do, what are our services. Okay, then we'll move on to DevOps and what is DevOps, and we'll be looking at the DevOps principles and why you should be looking towards AWS for your DevOps needs, and the overview of the DevOps services. We have a couple of demos for you. We have 2 demos for you for the showing the complete CI/CD pipeline. So I think that's going to be really interesting, and this is where the major part of the presentation will be focusing on. And then we'll wrap it up by discussing the best practices, and we'll throw open the floor for you guys for questions and answers. All right. So I'll begin with what is CloudX. So CloudX IT solutions, we've been here in the market for more than 10 years now, and we have more than 50 cloud customers here. We've been backup and disaster recovery, end user computing. So
Sorry to interrupt, Osif. I think your voice is breaking.
okay, I'm sorry, just 1 second. Let me check my connection. Sorry. Okay, I'll be looking at, I'll just see if there is any issue. I'll try to connect over cable if it's possible, just so that we can have a more reliable connection.
No problem.
Okay, all right. Okay. So I'm just checking for that. In the meantime, so like I said, we've been an AWS Select partner in the UAE, and we've been part of Systrix IT, which is here for almost 10 years now. We are a software development company, Systrix IT, and CloudX is the cloud services and cloud consultancy division of it. And like I said, we have more than 50 plus cloud customers, from ranging from small to medium enterprises to large customers. And we have delivered projects on migration, cloud DevOps, backup and DR, and end user computing. So we've been fortunate enough to work with Reddington, and Reddington is Rahil, obviously, who's joined us as part of Reddington. So I think it's best that he explains the slide. Over to you, Rahil.
Thank you, Tosif. Hi guys, welcome to the webinar. I hope everyone is fine. So I'll give you a quick introduction about Reddington. So when we talk about AWS, Reddington is the exclusive distributor of AWS for this Middle East region, right? We are doing distribution for other product for quite some time now, almost close to 20 years, right? So AWS is not the only product that we distribute, but there are a bunch of products, right? So if we talk in terms of AWS, we are advanced consulting partner, right? We have a team of 10 professionally certified individuals close to 30 cloud practitioners certified resources and 20 associate level certified resources. Apart from that, we are AWS well architected partner. So when we talk about well architected partnership, so we are we are a well architected partner, so we can do an audit. We are certified for doing audit on AWS infrastructure, and we are also authorized for AWS Marketplace product as well. So that's a quick introduction about Redington. So here we have offices all over Middle East. We have our head offices in Dubai, and we have branch offices in Saudi, in Kuwait, Qatar, and other regions of Middle East. So it's a quick introduction about Redington. Over to you, Tausif.
Thank you. Thanks, Rahil. So we'll begin with the we'll begin with the technical session. So the first question to ask is, what is DevOps actually? We've had a lot of people, come up with different ideas and different answers for this solution. But I think AWS has one of the best, answers to this. So what is DevOps? Is the definition and what the guideline given by AWS is that it is a combination of cultural philosophies, practices, and tools to increase the organization's goal, which is to deliver applications and services at a high speed and high velocity with high quality of product. Okay, so this is what is DevOps in terms of it. So to better understand what DevOps is, actually it is important to understand what it is not. Okay, and this is where we come in. What is DevOps not actually? So basically, DevOps is not a combination of the dev and the ops team. Okay, so we've seen a lot of organizations who mistake this, that they will just combine both the teams and bring both the solutions together, brought the teams together, and it's really not that, basically, because DevOps is it's a combination of processes and practices which are adopted throughout the delivery pipeline, and they span multiple stakeholders. It's not just one team or one operation that needs to do it, and you can just combine both the teams. It is across it's across the length and breadth of the software development life cycle. So there are key practices for both what is called as continuous integration and continuous delivery. So it is not just a combination of the dev and the ops, existing devs and ops teams, because there is a lot of additional things that come into play, specifically with regards to collaboration and with regards to how the product is delivered. But having said that, it is also not a separate team. So many organizations then they decide to have a separate dedicated DevOps team. Apart from the regular development team and the ops team, they have a DevOps team. So again, this is not what DevOps is, basically. So DevOps, like I said, it is for everyone, and it has to be across the complete life cycle and the complete chain of responsibilities and stakeholders which has been shared across. So it is not a separate team. Creation of a DevOps team, it is generally created as a temporary fix or a temporary solution when you're adopting DevOps. Okay, but to have a complete team permanently is not something that it will lead to creation of silos, and it will actually ultimately it will not help you deliver your products fast. It will actually slow you down. Okay, so it is not a separate team also. And again, the third thing, it is not a standard. It's not like ISO, or it's not like it's not like there's one single formula for everyone. It's not a one size fits all strategy. DevOps is very flexible. You have different business drivers and different tech stacks, and all of them have different needs, and they need to be solved with different solutions and different products. So this is not, there's no one single silver bullet, as they say, for DevOps. So it's not a standard. It's more of a process thing. Again, a fourth thing, what we hear commonly is people say that, okay, we have a lot of automation in place, so we are DevOps, or we have a DevOps function. Well, yes, I mean, automation is a big part of DevOps. Okay, and definitely you cannot have DevOps without having automation, but that is not it's not just automation. Okay, like I said, there is the other key part is the culture, the philosophy of DevOps, and every member needs to understand what DevOps is to basically have the value delivered to you. And the last thing is, a lot of people say that DevOps, we use Jenkins, so we have DevOps, or we use, Chef or Puppet or something like that, and so that's why we have DevOps. So, well, again, just like automation, it is not just when you implement one single product or something like that. Yes, you have a lot of tools available to you, and you have a specific tool chain which you should pick and choose. Okay, but having said that, again, we come back to the same thing, that it is not just these products. It's a combination of everything. To basically sum it up, you would say that DevOps is basically a business drive and to improve communication and collaboration between the development and the operations teams. Okay, and to increase the overall speed and quality of the software product at the end. At the end. So it is more of a again, it's a philosophy, it's a culture, and you use existing products, you use existing tool chains to achieve those. Okay, but at the end of the day, it's a cultural difference that comes into place when you say that you're implementing DevOps in your organization. Yeah. So I'll give it up to Rahil now to look at the DevOps principles and take it on from there for the next few slides. Rahil.
Thank you, Tausif. So we'll discuss about the DevOps principle. So first of all, it's very important to understand why we are implementing DevOps culture or why we are having a DevOps culture, right? So the overall idea behind using DevOps culture is to minimize downtime, right? And to increase the velocity at which we do the software releases, to manage our software releases properly, right? To make sure that each release go through thorough testing process, right? To make sure that each and every software release is consistent and there are minimum of bugs, right? If possible, no bugs at all. And we also want to make sure that each release goes through, a step of monitoring process, and we want to have some kind of alert mechanism where a set of users get alert if something if some changes are happening, right? So as Tausif said, it's about collaboration. So each of the team, let's say the operations or the developer teams, they are all aware of what is happening. They get the alert, and we have we call DevOps as a two pizza team, right? So the team should not be too big. At the same time, team should not be too small. So two pizza team is the right terminology. So you have a set of individuals who own the responsibility for for a particular aspect of a software. So we call it microservices. So it's called microservice architecture, where you uh, divide, or I should rather say, where you create services and you combine those services, and then you get the whole application. So you may have microservices for if you're building up an e-commerce application. So you may have microservices for payment. You may have microservices for customer management. You may have microservices for inventory, like that. So each and every microservice will be managed by a team, and they have full control over those services, and they manage the release process. That's the idea. So if we talk about uh, previously how applications were released, so it was a big monolithic application where a complete a code is rolled out at once. And when it comes to troubleshooting, when it comes to identifying bugs, it becomes really difficult to identify what happened when some releases doesn't work in an expected manner, and you have to troubleshoot. It becomes nightmare, right? Because you have such a big monolithic application. But here with DevOps uh, culture and with microservice architecture, the teams know what is happening, right? And the actions can be taken right away. So this improves agility, this improves productivity, and at the same time, it also allows you to make frequent releases. I'll give you one more example. For example, again, let's take the example of an e-commerce application. So if you have to make changes in your payment system, the other services which is related to customer management or which is related to your inventory will not get affected. So this allows you, to make frequent changes in in uh, in in any of the microservices, because these are independent. Not only that, the developers can use their preferred tools. For example, if a development team are comfortable in .NET, let's say, they can use .NET uh, for building for writing the microservices for for billing, right? Or if a team is comfortable in Node.js, they can use Node.js for writing microservices for customer management. So likewise, we have a team can use their preferred tools, their preferred languages for writing codes, right? So this gives you more option, and there's open space for innovation, right? So we'll discuss about a DevOps principle. It's all if you see it's if you see the shape, it's infinity. So what it means, it's a continuous process, right? It's not one-time process where you just rolled out an update and then you are done. So it's a continuous process, right? So you have planning stage, you have then your coding stage is also there. Then you'll build your code. It has to be tested. That's the development part, right? So a developer will plan what are the microservices that he needs to create. Then he will write code for these microservices. Then the code will be built and it will be tested, right? And then the release management will happen. It will be released and then deployed, and there's an operate phase where it will be operated, and then monitoring will happen for the overall process. So if you see, we have combined dev and ops process, and that's why it's infinity, because after monitoring or after, I would say, deployment, you are not done, because the process has to evolve. So if there is a requirement to make changes in the next release, you'll follow the same paradigm, right? And as we'll see in the next slide, we have bunch of tools available for all these stages, right? When we talk about planning stages, so planning, many people prefer Google Docs, or people prefer Office suite of application to do, to plan the software releases. MS Project is a classic example, right? When we talk about coding, so it could be your preferred language, which comes with its own IDE. So you have control over what you're writing, what programming language you're selecting. Build stage, we have number of tools. So as you can see in this slide, so build can be anywhere. So you can use, for example, if you talk about in AWS term, you can use code build for building your code, right? Your code can run anywhere. It can run on Docker, and you can use Kubernetes, right? So application can run on any type of infrastructure. But the idea is, uh, always remember the infinity that we discussed, right? So once it is built, you have the CI integration, right? You want to integrate with the CI tool. Then a good example of CI tool would be Jenkins, very popular. Everybody uses it for release management, right? And similarly, you have tools for deployment. So if you want to deploy your code, or if you want to deploy your update to a set of EC2 instance, or to virtual machine, or to containers, you can use AWS code deploy, which can integrate uh, with the with your build. So if you are using Jenkins, it can work with Jenkins also. If you are using code build, it will work with code build also, to roll out your update or to roll out the deployment. Similarly, tools like Chef, Puppet, these are also available. So you can leverage that, or maybe Ansible also can be used to deploy your code in a seamless manner, or in an automated manner to your backend target. Finally, for operate stage also, we have number of tools. So you can use Zabbix, because operation means to keep track of what is happening, or to to see what is happening, and to log what is happening, right? So you can use Zabbix, you can use Datadogs, you can You can even use CloudWatch because you can create a live log stream in CloudWatch, and you can go through those logs, so you have so you know what is happening inside your uh, release, or what is happening in your uh, software releases. Yeah, and we discussed about all these stages. We can have a continuous flow using code pipeline. So if you want to define your flow, how the software release should go through, uh, then you can do it. You can orchestrate it through code pipeline. So all these stages can be put as a flow, and code pipeline will ensure that any release will follow the flow that we define, right? So now with this slide itself, you can guess some of the advantages of DevOps. Gone are the days when people used to update, manually update each and every server, and they put the new code on the server. No, that will not work when you have a big application. When we're talking about 80 or 100 servers, or if you're talking about a global application which is very popular, this approach will not happen. You have to you have to follow DevOps culture here, right? All right. So now we know DevOps principle. Now we understand why we need DevOps. Let's discuss why AWS for DevOps, or what AWS offers for DevOps folks, right? So the first advantage of using AWS is that you can get started really quickly. So if you are new to DevOps culture, you want to play around, you want to learn something, you don't have to spend a lot of money to uh, to access those services. So you can get started really quickly, because there are built-in services which AWS offers, and you can use those services to start your uh, DevOps uh, DevOps journey. Then AWS also offer fully managed service, which we'll see in the next slide. So there are services which AWS fully manages. So you don't have to manage the backend server. You don't have to manage the connectivity. You don't have to manage the networking aspect. It's all available to you, and you can use those built-in services to kickstart your DevOps journey. AWS is designed. Uh, it's always designed for scalability, right? Any of the AWS service will have the scalability component in it, and DevOps is not an exception. So when we talk about managing one pipeline or managing hundreds of pipeline, that's not a problem, because these are all managed services, and you don't have to invest on heavy, you don't have to make an upfront investment to get started. So these tools are available for you. You can start at a very small cost, and then you can go big, right? Another advantage is it's programmable. So you can have a template, you can define a template, and then you can just run those template, and the infrastructure can be created for you, or the flow or the DevOps cycle will be created for you. So you can programmatically define how your software release should go through. You have automation. So automation is a key aspect. It's a key aspect of AWS. So all these services, all the DevOps services can be used to make the whole uh, software development process automated, where minimal of human intervention is required. For example, you may need intervention when you have to approve a release, right? That's where human intervention is needed, because the manager should know what is happening and what code you are rolling out. So apart from that, apart from these small things, the whole process can be automated, and automation is a key part of AWS DevOps culture. You can also use security services offered by AWS to make it to change your DevOps culture to DevSecOps, right? So you can use services like X-Ray. You can use services like Trail, You can use logging to make the whole DevOps process more secure. And then AWS has a large partner ecosystem. So there are a number of tools, there are a number of third-party tools that you can use on AWS. So if let's say you don't want to use code commit, you are comfortable in Git, that's not a problem. You can use Git also on AWS. If you want to use Jenkins, your team is comfortable in using Jenkins, you can use Jenkins as well. Similarly, if you are comfortable in using Spinnaker, if you don't want to use AWS native tools like code deploy or code build, that's not a problem. You can still use uh, your preferred tool. And these all tools are available in marketplace, right? And the biggest advantage is it's pay as you go. So you don't have to make an upfront investment. So you can start really with a minimal of infrastructure, and you can go big, right? So you don't have to make an upfront investment, and that's a very big advantage if you ask me, right? All right, so let's talk about some of the DevOps services, right? What AWS offers. By the way, these are not the only services. These are some of the services which you can leverage for your DevOps requirement. To start with, we have Code9, which is the ID, managed ID, right? So Code9, if you are not, if you want to use an ID on AWS, or if you're not having Visual Studio or any other ID, not a problem. You can use Code9. Again, it's it relies on behind the scene. It uses EC2 instances, but the management aspect of Code9 will be taken care by AWS. We have code commit. So code commit, it will be your repository for code. We have code build, which you can use to build your code, right? A code deploy can be used to deploy codes in an automated manner to your backend target. It could deploy a code on an EC2 instance. It could deploy code on Elastic Beanstalk, or it can deploy codes even on container, ECS, Kubernetes, you name it, right? When we talk about infrastructure as code, we have CloudFormation. I believe many of you will be familiar with CloudFormation, or you might have heard of Terraform, right? So CloudFormation allows you to create a template which you can use to provision the backend infrastructure in an automated manner. So the idea here is we're using infrastructure as a code. So we are defining what needs to be created, what time, and when we run the template, the whole infrastructure will be provisioned for us, right? So it's very handy. So if you have your working infrastructure, and we'll see in the demo also how we are using CloudFormation to create our infrastructure. Similarly, we have service catalog. We can use service catalog to assign set of services to our team, right? We can expose some of the AWS products, some of the AWS services to respective team through catalogs, right? So we can make sure that, okay, development team A can access, let's say, ABC services, but development team B can access only XYZ services. So we have control. We can do that through service catalog, right? And if we talk about monitoring, we have X-Ray, we have CloudWatch, we have CloudTrail. So X-Ray, it really allows you to identify what are the bottleneck. If you are experiencing slow performance in your application, you can troubleshoot and you can identify your bottlenecks easily through X-Ray. CloudWatch, it's for general monitoring. So you would know what is you will know what you can check different metrics for your services, and you will identify how much is the consumption, and you can identify the resource utilization in real time. You have CloudTrail. This is basically for auditing. When any users make any changes in your AWS infrastructure, that will be logged, and you can revisit trail logs to see which user made what changes. So I highly encourage to enable those services so that you have visibility. Now, in terms of container support, in terms of containerization, AWS gives you multiple options. One is ECS. So ECS is a managed service from AWS where it can manage your clusters. Sorry, where AWS can manage your containers, and the cluster will be deployed to manage your set of containers. Then ECS comes in two offering. One is where you manage the AWS infrastructure, and one is the serverless offering of ECS, which we called Fargate, where the underlying resources, underlying nodes will be managed by AWS. That is in the Fargate offering. So similarly, we have repository services for container. It's called ECR. And for containers, we also have managed Kubernetes cluster, EKS. AWS also offers EKS Fargate that is also available. Not in Bahrain region, but soon it will be available in Bahrain also. Now, in terms of platform as a service, where you want to, do a one-click deployment of your application, where you just upload your application, and the whole infrastructure will be created for you. If you talk about, if you're talking along those lines, so Elastic Beanstalk would be the tool for you, where you can upload your code and the whole infrastructure will be created for you in the backend. And we'll explore these services in the demo as well. So that's in a nutshell. I mean, these are not, I will not say, because AWS have more than 160 services. So I'll not say these are the only DevOps services you can use, but these are some of the core DevOps services which AWS offers. Right. Now, for the demonstration of CI/CD containerized application, which is our first demo, so I'll hand it over to Tausif to run through the demo. Over to you, Tausif.
All right. Okay. Thank you, Rahil, for the detailed explanation. All right, guys. So what I'll do is we'll discuss what the architecture is first, and then we'll move on to the application and the CI/CD demo that we have waiting for you. All right. So as you know, as explained before, to implement what we are talking about, CI and CD, for those who, who are just beginning out, is that it's continuous integration and continuous deployment. And, as Rahil explained in one of the earlier slides, integration is basically where you have you are building where you're pushing your code, you're integrating your code into one place and building it. And then deployment is where you're deploying to multiple endpoints. So that's a continuous integration and continuous deployment, and it works as a pipeline. Okay, so it begins at obviously on the left hand side, where you basically the developer checks in the code, he pushes the code to a repository, and on the right side at the end of the pipeline is basically where the application is automatically deployed. So this is the whole pipeline. It has a number of steps in between. The primary steps here are, as you can see, you have source, build, and deploy. And in these basically the points here is that what you will be looking at is the source is the code, the developers will be checking in the code to code commit, which is the Git repository service provided by AWS. In the code you will be having obviously your own code. For this example we are looking at a .NET application. As along with the .NET application code, you have to have one more file, which is called the build spec.yaml file. And this YAML file is what is actually used to build the code, and is basically providing the specification of what needs to be built and how it needs to be built. That specification is provided by the build spec.yaml file. Obviously, this is also checked in as part of the Git push and Git commit. It is checked in over there. And as soon as it is the code is checked into the code commit, it actually triggers off an event. Okay, and that event actually kickstarts the complete pipeline process. So at the till the very end, this full process is managed by the AWS pipeline, and we can monitor and we can see what's happening along each of those stages. Okay, so as soon as it is committed, like I said, it will kick off the code build process. The code build will look at the build spec.yaml file, and it will start building the application. Okay, you obviously have different images of which you can use to build your code. So you have Windows images, okay, which you can build. So for example, if you're using a .NET framework app which works only on Windows, you can use a Windows image to build the Windows code. Otherwise, if you're using anything else like let's say you're using Docker, you're building Docker images as we will be in this demo, or you are using Node.js or Java or anything, so which can be built on the Linux application also. So we will be using a Linux image to build this. Code build will be using Linux image to build the code. Okay, so once it is built, once the code has been built, there are some artifacts which will be created. Okay, so whether if it's a Java application, you will have a Java output file, where if it's a Windows application or a .NET framework application or a .NET core application, it will have some DLL files, and it will have some packages which are created at the end of the code build. Now, this is what these packages which are created are what is basically known as artifacts. Okay, so in our case, for the containerized, the application is containerized. Our artifact is basically a container image. Okay, and the container image is pushed to the ECR, which is the Elastic Container Repository. So this is where you can store your Docker images. It's like Docker Hub, but it is your own private Docker Hub repository, if you can say that. Okay, so the container images are pushed there, and once it is pushed, it will move on to the next step, which is to deploy this image. And that image is deployed using this basically you have a file which is also generated, which is the definition file, and this definition.json file is taken in by the deploy stage, and it knows what image needs to be deployed where. So in our case, we are going to be using the container image we just created, and we'll be using it to deploy on Elastic Container Service, ECS, and we are using Fargate, so which is Docker as a service, which is completely fully managed Docker service provided by AWS. Okay, and we have a container running on top of it. Okay, and in front of that, to go to the internet, we have an application load balancer in front of it. So basically, the point of the load balancer is that if you have a large scale, to scale the application, you will be having multiple Docker containers. And the point of Dockerization or containerization is to have a scalable application or a flexible application which can scale up and down, as the traffic grows or as the traffic reduces. So to manage that, we obviously need to have a load balancer in front of it, which basically from where everyone can access it. All right. So I'll just close the presentation for 1 second. Okay. And I will show the. All right. So I hope you guys can see my screen. Are you able to see it?
Yes, Joseph, we can see your screen.
Okay, great. So over here, basically, if you need me to zoom in, I'll zoom in a little bit also. So like I said, this is the code commit application. Okay, this is where our repository is hosted. We have the I've named it the DevOps demo project, and you can see this. The project is here. We have the buildspec.yaml file, which I told you about. Okay, we have since this is a .NET application, we have the SLN, the solution file, and we are using Docker Compose to create the Docker images. The code is inside this folder. Okay, we don't need to go inside the folder, but this is where basically the code is. All right. So what I'm going to do is once I check in the code, okay, it's going to come to this pipeline which I've created. All right. This is the demo pipeline, and the pipeline is having 3 stages here. One is the source stage, okay, which is having the code commit source stage. From there, I've added this as source. Okay, from there it's going to go to the build stage. Once it succeeds here, it's going to go to the code build stage, and then it's going to go to the code deploy stage. So the build is basically where we have selected what image we want to build and how it is going to be built. So for this purpose, for the purpose of this demo, I've selected a .NET Core app which can be built with a Linux application also. All right. So we have selected the environment to be Linux. Okay. And in the Linux environment, we have selected. So this is the image that we have selected. This is an Amazon Linux 2 image that we have selected, and this is what we are going to be using to build the Docker image on of the .NET application. And after that, we have the repository here. Okay, so this I've named the the Docker image as hello world, and you will be able to see the latest one once it comes up. Once it is updated, you will see the latest one come here, and this is our container cluster, which is being used to show the file, or which is being used to host the container for us. Inside this, we have the container service, which is a load balance service. And this is where we are having one container running over here, one container which is running. And once we deploy it, you will be able to see it will become two containers at first, okay, with the latest one being the one able to see this finally from the load balancer. Okay, so this is the all right. I think there was a glitch a few minutes ago. So I hope you guys can still see my screen and hear me, right? So this is the application. Okay, this is just the demo application that is hosted .NET Core application. And to show that what is happening, I have the image here, and I've changed the message to welcome to DevOps Master Cloud by CloudX and Reddington. Okay, what I will do now is I will update this message here. Okay, and then we will see how the flow goes and how it's working and what's happening. All right. So for that, I have I will open my IDE of choice, which is Visual Studio Code. Okay. And what we are going to do here is we have this is the code on the left hand side. As you can see, you have the YAML file, Docker Compose YAML files and everything. Here is the index.html that you're seeing, and this is the message that is shown here. Okay, so welcome to DevOps Masterclass. So we will change it to thank you for attending the DevOps Masterclass. Okay, I will change this. Okay, I'm going to save it, and I will add the Git and commit it here. All right, and now we will push it to the Git. Okay, so now it's already pushed. So if we come here to this code commit, we should hopefully see an update here. So you can see it's just been updated, DevOps demo. Okay, and if we come to the pipeline now, and if I refresh it, okay, so you can see the pipeline has already been kicked off, and it says the revision is the one which I gave now, updated index.html. Okay, if I go here, it has already taken in the source. It has already downloaded the new source code, okay, from AWS code commit. So you can see it is already uploaded, and now it is executing the build stage. Okay, so if I go to the build stage here, you will see the build is already in progress. And this is where the progress is. We can see the logs as as it is progressing. Okay, let me close that out. Okay, we have multiple phases in the YAML file. Okay, so these are defined in our YAML files. If I come here to the build spec.yaml file, you can see we have defined install phase, pre-build phase, build phase, and post-build phase. This is the same thing which we can see here. You have the pre-build phase, install phase, and build phase. So right now it is in the build phase. Okay, it's building you can see the logs over here. Okay, and once it is completely built, okay, we see there are no errors, there's no warnings. Okay, and it is now continuing the build. All right. So once this build is completed, it's going to say it succeeded. All right, so we can see the post build phase is also completed. It's already succeeded. It has uploaded the artifacts, and our artifact is going to be, which is a Docker file, which is going to be updated to the Docker hub for AWS, which is ECR, Elastic Container Repository. Okay, so we should see the latest one if I refresh here. So you can see one at 348.26.1. Okay, so the latest one is already updated. And now this is on the service, the load balance service. So you can see now there are two tasks which are running in the service. You can see two containers, two tasks are running, basically two containers. One is the old one which is running, the other one is provisioning. So this is the new one which is already which was just taken in. So we have two containers and both of them are having a different image. So we can see the logs over here to see what is actually happening here. Okay, so 44 seconds ago it has actually started one new task. Okay, this is the task which is started, it is still pending. Okay, by the way, the service is still up, so there is no downtime in the service. It's still showing DevOps masterclass here. This is the old one which is there. Okay, and if we come here, once the task is succeed, once the container is up, it's going to shift to the new one. So now if you see that it's already started, both of them are running now, and it is registered one target to the new target group, and it will start moving connections from the older one to the newer one. Okay, so you can see here it says it is deregistered the older container. It is started dropping the connections to the first task, and it is now already started the stopping the first task. So if I come here and refresh this page now, so if you see the first one is welcome to DevOps class. If I refresh this page, now it's already thank you for attending the DevOps masterclass. All right. So we saw the full step of the way, the full pipeline, how it updated. There was no downtime in it. Okay. And this was just a small demo of how things are happening, how DevOps or the DevOps pipeline can be carried out in the AWS. So what's going to happen now is basically you have both the containers running. Okay, and in the container you will see once there is a timeout for first container, which is 5 minutes. Okay, so once it starts shutting it down, there is a 5-minute timer which I have put in place. So once that 5-minute timer is out, the second task is also going to shut down, and it's going to become one task desired and one task which is running. Okay, if I have so I mean, this was just a peek of what we can achieve with AWS. All right, and obviously we can define, we can drill down, and we can actually define how the services will be shifted from one place to another. So if you see here, it directly shifted from one task to another. In production workloads, obviously you do not want all your connections to go from one, once you update the container, we don't want them to go all at once. So you can actually have a deployment where the load balancer is going to shift only the 10%, then 20%, then 15%, or it will shift slowly. It will shift them to the new one, and once all the tasks have been shifted, all the connections have been shifted to the new one, the older containers will be stopped and closed, right? So obviously we have a lot of arrangement in place. You can do a blue-green deployment, as it is called. Okay, but this was just a sneak peek of what you can achieve here. Okay, and once we come here, you will see finally to the DevOps pipeline is that you will see the build is succeeded, but the deploy is still running. Like I said, it's running only because there is a 5-minute timeout. Once the 5-minute timeout will close, it will shut down the first container, and it will say the task is completely succeeded to finish. All right. So this was a demo. Okay. We have one more demo, which will be by Rahil. Okay, and Rahil will explain the architecture for it. So let me get back to the presentation. Okay, and I'll hand it over to Rahil now.
Thank you, Tausif. That was really interesting. Wonderful to see how seamlessly we can build our code and how seamlessly the whole code can be rolled out. That's really wonderful. All right. So for the second demo, which is CI/CD using PaaS. So PaaS, for PaaS offering, we are going to use Elastic Beanstalk, right? So in this use case, what we are doing, we have a team of developers who will have access to certain resources. So those resources are exposed to the team through service catalog, right? And in the catalog, you will have the catalog will create an environment, a Beanstalk environment, where the application will run. The catalog also creates an environment for automated application management, which would be a Beanstalk pipeline. And we will create an ID basically. So because I don't have Visual Studio here on my laptop, so I'll use an ID from AWS, and I'll push my code through the ID. And of course, the service catalog will also create a code commit repository, and we will push the code to code commit repository. During the build stage, when the whole build code build process will happen, the artifacts will be stored in S3 bucket, and those those artifacts and those outputs will be used in the Beanstalk to create our application, which we'll see in the demo. So just to give you an idea, so this is how it will look like. So we have a team of developers who will have access to certain AWS resources, in this case, Elastic Beanstalk, AWS code commit along with code pipeline. So code pipeline will be created because we want to manage the whole deployment through code pipeline, as we have seen in the previous demo. There will be an ID which will be created through the service catalog. We'll use Cloud9 in this case, and the whole process will build the code. So whatever our code is, it will be built by code build. The validation and functional testing will happen here at code build. The artifact will be stored in an S3 bucket, and we'll use those artifacts, and we'll use the output to deploy our application in Beanstalk, and then we will roll out a quick update to see how the pipeline work, right? So let's get into it. So I'll just share my screen. Okay. Hi guys, so I hope you can see my screen.
Yeah, we can see it clearly.
All right, great. So let's go to our Beanstalk environment first. We have two environment here. One is a simple PHP application. Actually, let's do a demo for two application. Where first application, in the first demo, I will demonstrate a two-step pipeline, and then in the architecture that we see in the PPT, it's a four-step pipeline. So that we will demonstrate in the later stage. So those guys or those folks who are new to this code pipeline will get better understanding, especially with the two-step pipeline. So let's get started with a very simple example, which is our PHP application, right? Here we have a very simple PHP application running on an Elastic Beanstalk. So if you see, there's nothing fancy. Sorry, because I'm not a PHP developer, but we have a very simple PHP application, which says welcome to masterclass, right? So what we want to do, because we are demonstrating concept, so when we make any changes in the code, what we want, the code should be automatically pushed and it should be automatically deployed to our Beanstalk application. So in this case, let's see how we can do it. So let me go to the code commit. So what I have done, I have stored the code in code commit, right? This is where my code sits, right? And I have cloned this repository and locally. So I do have this repository cloned locally, right? In this, if I go to see demo, you can see that I have cloned this repository. So the two important files which we are dealing here is index and appspec.yaml, right? So first I'll show you appspec.yaml because this is the file that will do the deployment. So it's very important to understand what is there in the appspec.yaml. So nothing fancy because it's a very simple application. So I have defined what is my source, what is my destination, what step has to be done before installation, and what things has to be done for the installation. So before installation, as you can see, it's a very simple script that will run by the code deployment, and the timeout is 300 millisecond. I can change it, but that's fine with me. And where the deployment should happen, it should happen here in this directory. So now let's go to the home page and let's make a change. Welcome to the masterclass, and let's add hope you are enjoying the demo, right? So I have made the changes in my local repository. Now let's add it. Oh, sorry, I have to get into the repository first. My PHP demo, right?
Rahil, I think you need to close the H1 tag. you need to put the slash to close
Oh,
it.
I'm sorry. Yeah, my mistake. Thank you. Looks fine now. All right. So let's add it one more time. Let's commit it and give a message, update heading, right? And let's push it. All right. As we can see, our code is getting pushed, right? Done. So if I go here, I should have updated index file, right? So we have the updated code. What it should do, it should trigger my pipeline, because my pipeline, the first stage of my pipeline is with the code commit. So as you can see, it's deploying my code and it's in progress, right? So that is done. I have added a manual approval step. This is just to demonstrate that any release can go through approval process. So an approval can be automated, or it can be, you can integrate SNS topics so that the approval goes to users' email, or you can integrate with Slack. But here it's a very simple step. So I'll manually approve my change, right? So it's approved. Now it should start the deployment. If I just refresh my screen, and it says it's in progress. We can go into the execution step. We can go into the execution history and get more information, right? For example, you can see the steps here. You can see the timeline. And deployment stage is in progress. So if we click on deploy, we can, oh, it's already succeeded, I believe. Okay, so let's go back to our pipeline. And we see that it is deployed. So let's go back to our environment, our Beanstalk environment. Sorry. Okay, let's refresh it. And we can see the logs as well, right? These are the things that happened to our Beanstalk environment. We can see the recent events. And if we go to the URL and just refresh it, and you see that my changes have been rolled out. So this is a very quick example where we have demonstrated how you can quickly roll out your changes in an automated fashion. So I never logged into any EC2 instance. I never logged into any of the web server. I executed everything through code pipeline using git commit and code deploy, right? And now you can realize the power of this tool, because if you have hundreds of servers to manage, it becomes really difficult. And that's the beauty of DevOps. So even if you have 100,000 servers, doesn't matter. The codes can be rolled out in an automated manner, right? I can have a complex environment where I can have a load balancer. I can put hundreds of servers behind the load balancer and then update my code. I don't want to do that. I want to, keep things simple for the demo. So just wanted to focus more on the concept rather than, capability. So that's my first demo. Now for the second demonstration, I'll go back to service catalog, because if you recollect our architecture, the developers will have access to certain AWS products and services. And these products and services are exposed through service catalog. So for this demonstration purpose, I've already created a service catalog, and you can see that I'm exposing only Cloud9 IDE, another Beanstalk environment, which I'll show you, and a code pipeline for Elastic Beanstalk, right? I can be picky. I can select users who should have access to these service catalog, who can run the deployment. I can give permissions. For me, it's fine. I mean, I've just given administrator access. So I already have a group called org admin, and I've given that group access to use that template, right? Now, if we go to our Beanstalk console, and if I go to application, I have another .NET application here, right? And you can see the health is green here. My application is working fine. And if I go to the application, sorry, I just have to drag it here. Oh, I'll drag it rather here. Okay, much better. All right. So it's again an ASP.NET application, right? Bit complex than the first one. We have more options here. We have an about page, contact page, and the back. It runs on ASP.NET. This application was deployed through Elastic Beanstalk, right? And currently it is in healthy state. Now we have also created a pipeline for this application. If I go to code pipeline, and this is my pipeline. So you see, this is not a two-stage pipeline, but we have multiple stages here. The first stage is to get the code from code commit, right? And then to build and validate it. After that, deploy the code to Beanstalk. So we have added those steps already, right? And just to give you an idea, I'll go to code commit. And show you that my code is actually in the code commit, right? So we'll use Cloud9 ID to edit and to work with the code, because I don't have Visual Studio here. So I'll use Cloud9, sorry, ID. See. So let's open the IDE. Actually, it's already there. So here in the ID, you can see, oopsie, something happened. It should be here, right? All right, so you can see that we already have cloned our repository .NET app repository in Cloud9, and we already have set up our build.yaml and deploy.yaml file. So it's already there. Now what we are going to do, we are going to make changes like we did in our PHP demo example. We are going to make changes. But here, one additional thing will happen. Our code will be built, right? It will not be deployed because in PHP application, we had nothing to build. It's a simple HTML changes that was happening. But here we are going to make changes in the home page or in view, right? And our code will be built because it is running on ASP.NET. So whole code will be built. We have already created a YAML file for build and deployment, right? So let's go ahead and make some changes. Welcome to masterclass. We'll add the same heading here as well. Slash h2 h2. Hope you're showing the demo, right? Let's save it. Okay. And then we'll go to our terminal. We'll follow the same syntax. One thing which you'll notice, code commit also uses git syntax, right? So it's pretty much familiar. It should be pretty much familiar to use. If you're using GitHub, that's not a problem. Same command will work with code commit as well. Now we'll do a commit. We'll give a message. Tweet heading, or rather add heading. Okay, that's because I have the credentials stored already, so that's a warning. That's fine. And we'll push code.
Rahil, you need to check your battery. Yeah, I think your laptop is on. That's why it's slowing down.
All right. Yeah. I'll just get a charger. Right. Okay. So if I go to push, get a charger. All right. It's loading up. Fine. Okay. So we've pushed the code, right? Let's go back to the repository. Repository .NET app. As you can see, it was modified just now. So hopefully my index page would be modified. Right. We go to view. And we see the view CSHTML. Sorry, that's the view CSHTML. Not that one. We're actually making changes in view home CSHTML. Home. That's the one. Okay, so my new code has been pushed. Right. So we'll go to the pipe. We'll see the pipeline now. Okay, as you can see, it's in progress. And the execution started 1 minute ago. Let's see what happened. Code commit is already successful. Now build phase is going on. This could take a little bit of time because it has to create a build environment for you, right? Depending upon the build spec.yaml file that we have, it will create a build environment for me, and then it will build the code. So this can take some time, but we can see the progress here. Right, we can see the phase detail. Meanwhile, guys, while the code is being built, if you have any question, you can just put it in the chat, so we can go through your, we can answer your question.
Yeah, if you have some questions, you can just let us know. Me and
Sure.
Rahil are here to answer. I think once this pipeline finishes, we can come back to it. I think it will take about 8 to 10 minutes. We'll
Right.
just go over the pricing slide, okay, and then we'll come back to this in the meantime. Yeah. So I think
Correct.
it will just build it, and then we'll have a look at the. In the meantime, we can have a look at the pricing slide. So
Sure, Kaushik. I think
yeah,
yes, it's gonna take like 10 to 14 minutes. So let's
I will.
cover the other slides.
Yeah, so I'll share my screen in the meantime, all right,
Sure, I'll
and
stop.
cover the pricing. Yeah.
Sure.
Yes. So we'll come back to Rahil's demo, the second demo that Rahil has in place for us. Because what's happening in that, if I just go back to the architecture that Rahil is implementing right now, there is actually code building. In code build, there is validate and building. So there are some inside code commit, we have some tests which are already built into the code, and we wanted to show you those tests as well, but I think we are short on time. So what it's doing is running those tests, and then it's going to build the code, and it's going to run those tests, and that's why it takes these about 10 to 15 minutes. So in any case, we'll come back to this Rahil's deployment. We can discuss the pricing for the products that we have seen. So as you guys are aware, AWS is having a very aggressive pricing strategy for all its products, and some of the products that you saw today are they have we are very competitively priced. Plus, they have a very generous free tier also. So if you are just starting out to begin, you can make use of that free tier, and you can. And some of the services have full-time free also. It's not just for the first year, but even beyond that, you can get a free tier, and you can keep using those as well. So for code commit, it's free for up to 5 users, and you get about 50 GB of storage for free, and additional user is about $1 per user. Obviously, with code commit, you get all the bells and whistles that you require from a Git product, like pull requests and monitor. You get the pull request is there. There's the approval process that we said is there in code commit, which you find on products like GitHub or somewhere. So you get all of that, but it's just $1 per user per month. These are all per month prices, by the way. For code build, the product that we use for building the applications, whether you use Windows applications or Linux applications, you can use those images. It starts at, as you can see, it's 0.0005 per build minute. That's for Linux application with about you get 3 GB of RAM and all of that, but it starts from that. So it's very competitively priced, and again, you pay only for what you use. So you're paying only for every build minute. If you run a build every once every day, you just pay for it. You don't have to pay anything else. It's unless it's not being used. So this is the differentiator when it comes to using Jenkins, or when using some other products with let's say a product like cloud build, because we do not have. If you're using Jenkins, for example, you have to pay for the complete resource, the underlying infrastructure, the virtual machine, whether you are using it or not. and over here it's charged only per build minute. So that's the differentiator. You also have code pipeline, the whole pipeline which was actually managing end to end, which kicked off the which actually kicked off the building process and the deploying process, which you saw. That is charged at $1 per month per active pipeline. So just $1 per month. Okay. Again, when you come to code deploy is free for all AWS services. So if you're using it to deploy to an Elastic container, or you're using it to deploy to Beanstalk or EC2, or wherever you're deploying on AWS, it's free of cost. So there is no cost at all for any code deploy. You can also use code deploy to deploy on-prem applications. So in case you are running like a hybrid cloud strategy where you have applications on cloud as well as on-prem, you can use code deploy, the same code pipeline, to deploy on AWS cloud as well as on your on-premise servers. And for that, it charges about 2 cents per deployment on the on-prem. So let's say you have 10 servers, and 10 servers you deployed, you run one code deploy, it's deployed to 10 servers. So it's going to charge you 10 into 2 cents, so about 20 cents to deploy to 10 on-prem servers. So per deployment basically. So that's code deploy. When you come to Cloud9, the IDE which Rahil showed you on which was running in his browser, it's free of cost. Okay, but you have to pay for the underlying EC2 because it runs on virtual machine. So EC2 and the storage that it takes up. So you pay only for that. But it's like again, it's only pay for what you use. So you can have the Cloud9 IDE running, let's say 8 hours a day if your developers are coding full time, and you can have a 30-minute hibernation time for it. So if it's the IDE is not being used for 30 minutes, it's going to save the work and it's going to shut down. So you don't get billed for that. Okay. So every time you want to start it up, you can just say start now, and it's going to be available for you at the moment. So if you guys are working 8 hours a day, 5 days a week, you don't have to pay for the full month, 30 days. You just pay for the number of hours that it's being used. So even for that, and Cloud9, the application is free of course, you just pay for the virtual machine that it's being used on. So again, it comes to very, very competitively priced. There is no basically, so if you have, let's say, a couple of developers who are running developing only half of the time, like 4 hours a day, so you just pay for 4 hours a day for 20 days or 30 days or whatever. So it becomes really, really cheap, really, really competitive. And the Fargate that we saw, so Fargate is the as I mentioned, is the container as a service program. It's basically what your containers are running on. And in the Fargate, again, you pay for the each you can have customized containers, so you can choose how much CPU you want and how much RAM you want, and these are the cost for each CPU and each RAM. So if you have, let's say, 2 CPU 4 GB RAM machine, so you're going to be paying whatever this is for 1 hour for that. So again, very, very aggressively priced and extremely competitive pricing. And you don't have to pay for things when they're not in use. You don't have to pay for anything. Okay, so you can have either with managed services like code commit, code build, or code deploy, you use them, you are build only when you use them. Okay, or with like Cloud9 or other services, when you don't need them, you can have an auto shut off or auto hibernate policy. So you basically are not billed for when you are not using it. Right. So this is a pricing strategy. I think if you have any projects that you need to deploy on DevOps projects, you have to have a look at AWS offerings because they are very strong. Okay, like I said, you don't need to manage any of the services. There are a lot of security options in it, and the best thing is the pricing is very aggressive. You can start very small, and you could you can obviously use a free tier, and if you're just using it for small applications, I'm sure you will not even exceed the free tier itself. So it's really competitively priced, and I think you should definitely give it a shot. Right. I will let's have a look at Rahil's slides. Okay, and let me check if anyone has any questions. If not, then we'll move to Rahil's environment and see if the deployment has completed. All right, no. So there's no questions as of now. Okay, Rahil, you can take the stage. You can see if the deployment is completed. We can show
So
it to them, or we
sure.
can, yeah, we can move to the next slide if there's time.
I'll start the process of onboarding.
Tausif, I think the build stage has completed.
Thank you, everyone.
Deployment is
Huh,
still going on.
huh.
So I believe we still have time to cover another slide.
Okay, great. Okay, so we'll move to the next slide, which is basically best practices. Okay, and what you should be looking at when you are implementing it, DevOps in your environment. So these are the best practices. So again, just to wrap things off, when you're looking at DevOps, you will have to implement. Like I said, it's not DevOps is not a framework, is not a standard. Okay, so you use whatever it suits to you. You have to find the right balance for you, but the best practice is to get an agile project management strategy in place. For the guys who are already aware of agile, it's basically, it helps you break down large projects and into smaller increments, smaller chunks which are more manageable. And basically it helps you to and with Scrum and Kanban, you're able to assign the task to someone, and you basically can deal with who will be doing what he will be doing, and when it will be completed. So basically, a project management strategy with agile using Scrum and Kanban boards is really it's basically a must, if I can say, to implement a DevOps strategy. Many people have the misconception that DevOps and agile are completely separate or they're different, but that's not wrong. Actually, agile is what helps you along the DevOps journey, and it helps you to roll out quickly, because the concept of DevOps, as we earlier mentioned in the starting of the session, is to deliver these software fast and in a better manner, and to have it have it at regular increments. So agile is what is going to help you with that. The second is what is best practice is called shifting left. Okay, so if you recall the DevOps, if you recall the DevOps icon that we saw, the infinity loop that we saw, on the left hand side was the dev and the right hand side was the ops. Okay, so shifting left is basically is towards the dev side, is what is called shifting left. And using CI/CD, you can actually shift left in terms of identifying let's say bugs or issues earlier itself with devs. Okay, so right now Rahil is building that code. It is having the validation inbuilt to it, so there is validation unit tests which are running into it. So with the help of CI/CD, you are actually able to move this to the developers to the dev cycle, rather than waiting for it to go to the quality assurance team or the testing team. Before that itself, it can be identified those issues. Okay, the second is what is called shifting security left. So shifting security left again is basically the concept where security is built into the application, into the development process itself, where all the developers have this mindset of having security being built into the application. So it gets identified. We have the strategy called DevSecOps now. So this is what is called shifting left, and this is one of the practices, best practices for devs. The third is to get the right tool chain. Like I said, you dictate what tool chain is good for you, what is the right stack for your what is the right tool chain for your stack, and there is no right strategy which fits everyone. You have to pick and choose the tools that you want. Obviously, you have to take in a lot of considerations. If you're, let's say, on AWS, you would be looking at AWS products which will help you to get those things into place, and which are very well integrated with all the AWS services. So getting the right tool chain. And the last and final, but not the last and final, is basically having a continuous feedback loop. So basically the feedback loop is to have it's for all across, again, for everyone. So if you have the developer, if you talk about the developers, the feedback loop for the developers would be to get informed if the pipelines are failing, or if the builds are failing, to get informed immediately. So you have notifications, you have systems in place which identify immediately to them why the build build is failing, why the pipeline is failing. That's the dev for the developers. For the product management team, you can look at performance issues, if the application is not performing up to standard, or if there are multiple bugs found, if there's some security issues, that comes to the product management team, and they need to be updated as and when that happens. So again, you have the tools in place to inform them when there are such issues they're coming back. So feedback for the product management team. And then finally, for the project management team itself, the guys who are running the show, uh, for them also there is a feedback loop, and that is basically to identify if there are any issues with the processes they have in place, or any of the tools that they have in place. So this is, they needs to have you need to have a continuous feedback loop to feed into all of these places, to have a continuous improvement into this. So this is where, these are the best practices for the DevOps scenario. And that's about it for the presentation. Okay, any questions or anything, you can reach out to me on email, or you can reach out to Rahil on email as well. Our emails are there. You can drop me a message on Twitter if you want. If you have any questions, you can do it now, and I'll hand it over to Rahil to show his finish his demo if it's ready.
Thank you, Tausif. Yeah, I think the deployment is done and
Okay.
pipeline is updated. So
All right.
I'll just quickly share my screen.
Okay.
All right. So all right. So I hope you can see my screen. So I hope you can see my screen. Everyone can see my screen, right?
Yeah, we can see it. Yeah.
All right. All right. So let's go back to the pipeline. And just to, because you remember we gave a commit message saying that adding heading. So that has been added, and you can see it succeeded. So if I click here, it took around 15 to 18 minutes to deploy and to build the code. So if I scroll down, I can see that my pipeline has executed. So if you want to see the details, you can go to each and every step, and you can see what each stage has done. The detailed log is also available, right? So you can refer to the log. So in case, why it is important, because in case if you get any error in your build environment, or if you get any error during the build stage, you can always refer to the build logs and see what is breaking. So here everything went fine. So we'll see the phase details, basically what phases occurred. So first job has been submitted, it was queued, then build environment was provisioned, source was downloaded, installed, pre-build, build, post-build, upload artifact. This is all very standard, right? And once the build is succeeded, it got completed. We have a completed entry in our logs, right? After the build stage, once the build was completed, oh, sorry, go back to the pipeline again. Right. So once build and validation stage completed, it got the pipeline took us to deployment stage, where we actually deployed our code to Beanstalk. Details are as follows. So you can see build status was successful. Everything is logged. So again, this logs will be useful if you get any error. For me, it's fine. Same standard process that you're all very much familiar. So a job got submitted, it was queued, then deployment environment was provisioned, source was downloaded, installed, pre-built, pretty much standard, right? The only difference here is the deployment happened to the Beanstalk. So let's see the Beanstalk environment. Right. Let me just refresh it. And these are my Beanstalk recent events. So you can see environment update got started at 4:25, right? and it got completed within a minute. So that didn't took much time. Now, if I go to my environment URL and if I try to access my application, I'll just refresh it. Actually, it's already there. So you can see this is the changes that we made, and that change got pushed to code commit, code repository, right? It executed a pipeline and changes were seamlessly rolled out to my Beanstalk environment, right? The only additional step here was there is a build and validation stage. So actually my ASP.NET code has to be built. So that's where it took time, because build generally takes some time. Build environment has to be created. So it took like 10 minutes. And as soon as the build got succeeded, my code got deployed to my Beanstalk environment, right? So this ends our demo.
All right. Thank you, Rahil. And what I will do is, guys, if before you exit, we have the post webinar form. It's a very quick survey, just 3, 4, 5 questions. If you could be, I've shared the link with you on chat, and if you could be kind enough to just fill it out, that would be really great. And you can come, always reach out to me or Rahil for any questions or anything that you have. And my email is on the screen for you guys to see. So I think that wraps it up. Rahil, anything else you would like to add, or anything else?
Just a quick check, Tausif, I just wanted to check with the attendees if they have any questions, so we
Yeah.
can answer it right away.
Yeah, let's check if they
So
have.
guys, 2 minutes. So if you have any question, just drop your question in the chat and we'll pick it up from there.
Yeah, all right. And yeah, I hope you guys can see the chat link. I mean, you guys can see the survey link, so you could fill it out if you can see it. Right? All right, guys, I think we'll close out the session. Okay, thank you again for joining. I hope the session was up to your standards, and you had this was an informative session for you guys. If you have any questions or if you have any things that you would like to discuss, you can just reach out to me or Rahil. And yeah, thanks everyone for joining. And if you haven't, if you could be kind enough to fill out the survey. All right, we close out the session now. Rahil.
Sure, Tausif. Thanks a lot. Thanks
All
for
right.
the wonderful demo.
All right. Thank you.
And I like to thank all the attendees as well. Thanks for attending the webinar. Hopefully it is informative to you. And if you are working, or if you have any kind of a project, DevOps project on which you are working, or if you need anything, not only on the DevOps side, but anything related to AWS, you can reach out to us. Right, we'll be happy to help you.